And so let's say that you have these models of the world of warfare, and what can you use them for? How are these models deployed? Is it for training or actually fighting real wars, or how does it work?
Yeah, so it's all across the board. So within my office, our guiding portfolio for these kinds of things, we're calling Mosaic Warfare. And you can see our little logo here behind me. The whole metaphor of Mosaic Warfare is, if you look as a contrast, a jigsaw puzzle, that's a highly engineered architecture. I'm creating an overarching effect with a composition of existing pieces, but every single one of those pieces is very carefully engineered to how it's going to fit into that broader picture. They're difficult to put together. They are very brittle and fragile once you've created them, and they're not flexible at all. So the mosaic analogy is to say, I want to, again, stochastic kind of model. I'm going to have a bag of tiles, so to speak, that are some arbitrary, perhaps even opportunistic distribution. I might have some control over the statistical distribution of those tiles, but I'm not going to specify exactly what any one tile should be. But I'm going to have confidence that I can piece those tiles together in some way that can still produce an overall picture. And oh, by the way, it's not just completely arbitrarily. I've still got some kind of substrate. I've got some kind of, adhesive or mortar. So I've still got a framework I'm working within. But I'm living with that uncertainty, the stochasticity of a bag of tiles. But now it gives me an incredible ability to flex and adapt. And in principle, I can create that adaptation with much less difficulty than designing a new jigsaw puzzle. And oh, by the way, it's much more resilient to disruption and to uncertainty because I can lose a tile, I can find one similar and throw it back in. So when you talk about modeling, we have to do modeling across the board with those kind of things. So some of our modeling goes into just how do we plan the mosaic. I can go back to the toilet paper example and say, okay, I know I've got a problem. I can't keep the shelves stocked. Can I use modeling tools to figure out where within my process my supply chain is breaking and be able to experiment with what are options to be able to create a more resilient supply chain. So we've got a program, for example, called Proteus that on the surface looks almost like a video game. And what it's actually doing, though, is allowing people at things like military universities to explore new types of force structure and to create notion of hybrid military units that could be designed much more finely and specifically to given mission needs. So that's an example of using this kind of modeling at a planning kind of stage. We've got a fair amount of modeling that goes on in how we design the networks we need, although that's a little bit less about modeling than it is about new networking constructs and communications, virtualization and interoperability kind of things. And happy to talk a little bit about that more later if you're interested. But the third place where the modeling really becomes important, and this is where some of it actually gets used in operations, gets back to how can we simplify the problems that human beings have to deal with in this kind of highly networked, very fluid, dynamic kind of architecture. If you're responsible for being one of those tiles yourself, how do you know what your role is supposed to be in this mosaic? And that's where a lot of our work in AI has come in. But in the spirit of abstraction and composition, it's all up and down these various different degrees or levels of a call it decision-making stack. So we've got some technology that is at a very high level. Think of that as the mosaic artist who's saying, I've got a certain function I want to have happen in the battle space, and I want to use a new collection of tiles to go conduct that function. What are the best set of tiles to use at this moment in time? And so it becomes automated modeling to make those high-level decisions. To your point about dimensionality and complexity, that decision maker using that model doesn't have to know anything about how to actually use that tile or how to, what other calculations might have to go in. It just sort of votes. The tile itself is working a lower level type of modeling, again, managed dimensionality, where it comes in and says, okay, someone asked me to serve this role. I don't know why. I don't have understanding of the whole battle space or commander's intent. Again, that level of complexity has been stripped away. I just know as a tile, I've been asked to do something. Can I do it? What calculations and modeling do I need? So that might be, for example, for an aircraft, just something as simple as route planning. Or we've got one program that's been looking at for collections of air platforms. How do you deconflict the airspace in this very dynamic manner? Again, none of those functions need to know that high level awareness. And then another layer of abstraction, the things that are doing things like that airspace planning, those modeling tools don't have to know how to actually actuate the platform. So there's a different level of AI that can worry about actuating platforms, actuating payloads. So each of these layers, and this is where my challenge problem comes in. If someone has a great model who's an expert out there on network theory, it'd be really interesting to say, how could we actually define a scaling law, based upon a certain number of interfaces, divisions, and boundaries in this notion of abstraction and composition.
Yeah. And so you came up with this idea of mosaic warfare as opposed to monolithic architectures, right? There is a huge rupture with the past. You gave a talk, when was it, in 2018, where you spoke about the problem of dominance.
You have a couple questions buried in there. So let me talk about the dominance one first. And actually, in some ways, I've really touched on it already. If we just change the terms a little bit, dominance, the way certainly the U.S. military has thought about it, is back to that very deterministic forecast-based model. I want to do lots of studies to try to predict what the future mission and the future threat is going to be, and I'm going to go ahead and by doing that right, just design something that is big enough and bad enough and high enough performance that it can accommodate all of those possible contingencies. That's the dominance mental model. And so what we're talking about instead of dominance is this notion of what we really need to be focused on is how do we achieve our objectives? Whatever those objectives might be. And frankly, I think this mindset can apply, again, outside the military, back to how can we make sure that people can buy toilet paper? It really is, how do I get away from this? I've got to forecast everything and I've got to provision for all possible contingencies, and instead, time compression. How can I be rapidly responsive and adaptive regardless of whatever the opportunity or the disruption is? So that's really what we were getting at with this notion of we've got to move away from the dominance mindset, because otherwise you're stuck in this classic cat and mouse problem. It's counter, 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 counter. As soon as you think you've built the biggest and baddest system, someone is going to now focus on how to either build the bigger and badder system, or just some countermeasure that directly, negates that capability. So instead of this dominance approach, we're trying. Another analogy I use, apology, I like metaphors, but it's like trying to pop a balloon with one finger. It's sitting there bouncing on your finger, and you can't get any leverage against it because however you push, it's just going to squeeze out somewhere else. That's the anti-dominance kind of approach. Dominance would say, I just want to make that as hard as a block of granite. Yeah, but then someone comes along with a chisel and a hammer, and your granite's no good. So I'd rather be the balloon than the granite.
How is this mosaic philosophy being implemented in phases?
Recently, I've been referring to what we're calling 3 waves of mosaic. And the reason for laying it out this way is that, as I mentioned before, we're right at the intersection between technology, but also culture and organization and process. And again, I don't think what we're doing is unique to the military or DOD. I've read a lot of articles about, in fact, this is going on right now in the commercial world, There's the Gartner hype curve that you're probably familiar with, or your viewers may have seen. A new technology comes along, and there's first this huge excitement over its adoption, and then people look at how it's being used, and all of a sudden they're not seeing quite the outcome that all of the hype seemed to justify. And then you get the opposite response that they call the trough of despair. And then ultimately, people who stick with it slowly claw their way out of that trough of despair. And you find out, well, what really is this useful for? And then you do see a little bit less hype, but adoption and real impact. A lot of what's going on in the AI world is similar right now. It's like, okay, AI is going to change the future. And companies that have tried to adopt it are like, okay, we're spending a lot of money buying whatever this AI stuff is. Where's my return? They're not seeing it. A reason for it is the exact reason why we've got 3 waves of Mosaic. And it's that you can't get, for really disruptive technology, you can get some marginal improvement if you just sprinkle in the technology, but you can't get the orders of magnitude kinds of improvements if you aren't simultaneously challenging your processes and your structures to go along with it. A business has to truly change its workflows and how it thinks about executing its business to get best advantage from automation. DoD not only is no different, DoD has an even bigger challenge because it's so locked in rigorously to doctrine and structure and tradition in a very disciplined manner. So what I'm seeing in these 3 waves, Wave 1 is really, to a large degree, outside what DARPA is doing right now. Although I'd like to say no different than the internet, taken a couple decades to catch on. We've been working system of systems architectures, at least going back to the late 90s when I was a program manager. And so we've been pushing this for a long time. And as recently as about 5 years ago or so, my office now was still working system of systems. And people would look at us like we were ogres with 2 heads. What is this system of systems thing? Give me my next fighter aircraft. So the fact that there's this whole joint all-domain push within the department is incredibly exciting. I also use the term monolith busting sometimes when I describe Mosaic. So system of systems is busting up monolithic platforms where I've got to have the sensor, the weapon, and the decider all programmatically, vertically integrated and technology integrated into one platform. So that's good. And so Wave 1 is where the big military is right now in starting to implement and experiment with system of systems. And so you got to start somewhere. So it's exciting to see this happening. Put some markers down, try some pilot projects, provide some tangible, concrete examples of how you can get advantage by disaggregating capabilities, distributing capabilities. So that's Wave 1, and there's goodness there. The challenge is we risk replacing monolithic platforms with monolithic architectures. And in other words, jigsaw puzzles as opposed to mosaics. And a lot of the Wave 1 joint all-domain activities are jigsaw puzzles. They want to study things. They want to figure out what's the mission going to be, what exactly is the set of stuff that I want to go wire together to conduct that mission, and then how am I going to manually go integrate all of those? And again, I'm not knocking it. You got to start somewhere. But if we stop at that point and say, okay, we're just going to replace the whole DoD with these tailored architectures, I would argue what we've done is replaced vertical stovepipes, the platform-centric monoliths, with horizontal stovepipes, the architecture-centered monoliths. And that frightens me if we get to that point, because as anyone who's tried to do system architecting knows, and you brought it up in your question about complexity, the more things we put together, that complexity grows geometrically. Building system of systems architectures is hard. So if we try to build the whole DoD with system of systems architectures, it has a real risk of just collapsing under its own complexity. So Wave 2 is where we're really focused right now. What we want to be able to do is to enable a military operator out in the field to say, I've got a bunch of stuff out there that itself maybe has an existing function that it was designed to go do. It in and of itself is a useful standalone capability. But now I've got a problem facing me. And it could be a new mission. It could be a new adversary. It could be a new environmental problem or whatever. How can I take what I've got and take this architectural mindset and build a bespoke to this problem facing me today? How can I build an architecture that addresses that problem facing me today with whatever I've got? So it's this notion of it's not everything wired together in a big mesh. It's looking for a federated approach. In this limited set of capabilities on a focused problem, there are these, subset of things that have to work together. And maybe they weren't designed to work together, but I've got a way to make them more interoperable on the spot. And so that's what we see as wave 2. I like to describe it as letting the warfighter do system architecting without realizing they're actually doing a technical act. They just think they're doing mission planning. But there happens to be all these technical wiring diagrams going on behind them. The challenge there, for those of your viewers who are old enough to remember the days of, like Windows 95, by the time we got to the 1990s with a personal computer, it was pretty cool because you have a computer at home. You could configure it the way you wanted. If you wanted a new printer, you didn't have to go buy a whole new computer just to get a new printer. So there were things that were tailorable architectures designed to whatever your need was. However, if you remember those days, adding a printer to your computer was not for the faint of heart. You had to tear open the box, pop in a card, put in a floppy disk and do manual installation of a bunch of specialized software that usually didn't quite work right. And so that's where we are with Wave 2. The technology that's coming out of DARPA is think of us almost as Dell. We want to create the environment for the warfighter where they can, again, focused on need, be able to piece together architectures just like in 1990 we would have put together our home computer. As an aside, one of the organizational things that I've been out there pounding the pavement about is we need a new function within the military that, for lack of a better term, I'm calling a combat support geek squad. Again, to use that personal computer analogy, For someone who didn't have the technical fortitude to rip open their computer to install their printer, they could call up Geek Squad. And so who is the support organization that can be out there 24/7 supporting operators? It's not like going back to one of the vendors or a program office, but yet they're more technically skilled than your typical flight line mechanic. So that's Wave 2. And that's the next logical step because we want to be able to demonstrate that we truly can flex to need. Wave 3, and I'm not, is as much of a evangelist as I am about these things. I'm not willing to push too hard on Wave 3 yet. But if we can prove and we convince even ourselves, let alone the warfighter, that they really can operate in this very fluid, more stochastic, build me a capability to need, it is going to change how we think about new systems. So think about how we're going to populate that palette with new tiles. The way we're thinking about Wave 2 is the tiles, the platforms, the weapons, the sensors, are all going to be more or less the current things we've got today. When we buy the replacement for those in the future, if we're wildly successful with Mosaic, imagine I go buy a new sensor. And I say, you know what? I'm not going to tell you what the performance requirements for this sensor should be. I'm not even going to tell you quite what all the functions have to be. And I'm not going to tell you how it's going to be used. But it's great. Trust me. But we're trying to enable that kind of a future where you could let innovators come in and say, I think I've got this great new radar. And I know it's got to be good for something. And you throw it into that palette of tiles. One of the interesting things, you asked about modeling earlier. One of the things we're even exploring with are sort of game theoretic models as a way to score tiles. In this future vision, we don't want to dictate how a tile is going to be used, how a particular, capability is going to be used. But we still, DoD has a finite amount of money. It's not truly an open market. So we can't just let the market decide the way, a commercial environment would. So how do we figure out how do we want to spend taxpayer money on these capabilities? So, we've contemplated using modeling tools against game theory to say, okay, someone brings me a new tile. It can be used in the course of this very fluid mosaic. Does it move the needle? Does this tile actually improve things? Does it make no difference? Hopefully it doesn't make things worse. But as a mechanism for deciding where to put future investment. So that's way down the road. We're doing some more fundamental research, trying to understand how we would do that kind of modeling and evaluation in the future. But right now, we just want to prove that we can be good geeks and help the warfighter build their Windows 95 computer.
Thank you for listening to this conversation with Dr. Timothy Grayson. And I also like to thank DARPA's communication team for making this possible. If you enjoyed this video, please leave a comment below, like, subscribe, turn on the notification bell, and support this channel on Patreon. This podcast will be also available on Spotify and Apple Podcasts, and you can find the links in the description below. Thanks for watching.